Hi guys. So this is example 7 of chapter 10.1. And so this is a pretty nice picture of what I was talking about in the first video of sound waves going through the foci and bouncing off. I mean, it wouldn't have to be sound waves. It could be a ping pong ball. I don't know. Anyway, so that's kind of the idea of that in 3 dimensions, and then here's another picture of it in 2 dimensions. So anyway, let's go ahead and look at this problem. So it says the statuary hall in the Capitol building in Washington, D.C. is a whisper chamber. Its dimensions are 46 feet wide by 96 feet long as shown in figure 13. So this is the dimensions. And so 46 feet would be our minor axis and 96 feet would be our major axis. So we're going to write the standard form of the equation of the ellipse. And then if two senators standing at the foci of this room can hear each other whisper, how far apart are the senators? So in other words, they want us to find also the distance between the two foci. So that is what we're going to be doing in this example. So I'm going to start by finding that equation. So we're given the only information we're given here is the length of the major axis and the length of the minor axis. So from that, we can find A and B pretty easily, right? Because the major axis, 96, is 2A, right? So A equals, what is that, 48? Yeah. A equals 48. And then the minor axis is 2B. So, whoops, B equals 23. So we have our A and B. That was simple. Let's talk about the center really quick. So here it gives a hint that we can let the center point be 0, 0. I would definitely agree with that. If you can make things easier on yourself, if you're not given a center point, this could be literally anywhere. We're just trying to find how far apart the foci are. So it's not set on a graph. It's a physical location. So to make our things easier on ourselves, we can just decide that the center is going to be at 0, 0, just to make things easier on us. So writing the equation from this point, once we've made that decision, is actually really simple. So if the center is at 0, 0, then we don't have to add anything to the x or the y. So we just have x squared over the x direction is our major axis. So we're going to have a squared, right? So if the major axis is in the x direction, then a is going to be under the x. So we're going to have a squared. So 48 squared is 2,304. Plus, we're going to have y squared over b squared. B squared. So 23 squared is 529. 529 equals 1. Always 1, right? So this is our equation. This is our equation. So this is the answer to A, right? So then B is asking what the distance between the two foci are. So we're going to use our Pythagorean relationship to find C, which is the distance from the center, right? The center to the focus. So if this is the center, then this distance is C. Why did I make it a loopy? I don't know. So if this is the center, then this is C, right? So then 2 times C would be the distance between the two foci. So that's what we're going to find. So we know that C squared equals a squared minus b squared, which is 2,304 minus 529. So that's going to be 1775. We take the square root of 1775. So we're going to get an approximate here. We take the square root of 1775, we're going to get approximately 42.131. And they want us to round to the nearest foot anyway, so I'm not worried about that. So the distance between the two foci is going to be 2 times c, which is to the nearest foot, because that's what they asked for. To the nearest foot, that would be 84. So that would be the answer to B, would be 84. They're going to be standing 84 feet apart. So that is how you would approach that question. Hopefully that helps, and I will see you in the next video.